Hi everyone, so today I'd like to introduce my experience. So first of all, it's my working experience. I've worked in a high-tech lab called PyLab in Xiamen University as a research assistant and an engineer assistant during my 1 year gap and some of my summer vacation during my undergraduate study. So in our team, I was responsible for designing the logarithmic current to voltage circuit. And after I finished my design, I also lay out several different versions of PCB with Autumn Designer and Cadence. So the instrument can measure the current signal down to the precision of femtoampere. We are measuring the linear output and the logarithmic output of voltage. So in the previous version, I designed a PCB like the one in the first column. We can see there are two circuits on one PCB. The first one is linear output, and the second one is logarithmic output. And then I figure out there were huge noise between these two outputs because when we measure such a low voltage, the noise can be a very big problem. And then I improve this kind of this PCB, and then becomes the second one. I put the power supply under the measurement circuit and hold the measurement circuit in the middle of the box, so it can improve the ability of noise shielding a lot. And also I've done several different kind of circuit and PCB to meet the special demands of PhD students and master students in this lab to help them finish their experiments. So here's something I've learned in this internship. I learned how to use Autumn Designer Cadence to design circuit and PCB. Also learn how to do circuit simulation using multisystem. Learn how to do data processing using MATLAB, and also there's a little part of the Apple computer is designed by myself by using LabVIEW. And when PCB finally came into our lab, I have to weld some different part of the important component like chips or some special resistance. So I also learned how to use oscilloscope to check if the PCB works in the way I want. And the most important is the manipulative ability. It's very important for me. And then this is my research experience. I've done several projects, and there are two very important for me. The first one is called cross-model representation learning, and the second one is called adversarial machine learning against voice assistance systems. So the first one, I and my team just apply cross-model retrieval for food AI using R1M dataset. And to reach this goal, we design like 3 different kind of structures. The first one is CCA models. The second one is nonlinear feed-forward neural networks. And the third one is cross-model transformers. So here's my first two structures. And we can see I use CCA in the first structure to do the cross-model learning. And then I tried triplet loss or MSE loss. And also I make some complex design in the end of the model to let my model learn more significant details about text and images, and then learn how to retrieve them. So the most important part is retrieval from image to text or from text to image. And then the final structure is that I use a transformer with 2 attention blocks to do the cross-model retrieval part. So this transformer can help this model to perform better. And then I use cross entropy loss to train the whole model. That is, this model perform much better than the previous 2. So during model designing and training, we also do several visualization, ablation studies, and also dimensional analysis. And here's our details. And from these projects, I've learned many useful skills like Python, PyTorch, and transformers. And I also remember the paper, "Attention is all you need." It is a famous paper, and also it's quite interesting. Also, I've learned several dimension reduction methods like CCA, PCA, PPCA, and kernel PCA, t-SNE. The reason why I can't introduce another project is because it's a very important project and it's still not finished in our lab. So I just can't introduce it. But I can say the second project is all about backdoor attack and adversarial voice attack. And here's my career goal. So my goal is just very simple. That is to, if I get my PhD, and I plan to join the industrial circle as an engineer. That's it. Thank you so much.